Hi, my name's Audrey, and today Kelly and I are going to teach you how to take the derivative of b to the x. The derivative of something is the slope of something at any given point. So the derivative of e to the x is actually e to the x at every point, but the derivative of b to the x is not b to the x at every given point. For example, we can take 2 to the x. The slope of 2 to the x, if at 1, is 1.386. You can figure this out using your graphing calculator. If you take your graphing calculator and under y equals 1, right, 2 to the x, then you graph it. You do second, and then trace. Press 6 to get the derivative, and then you put in 1. You get 1.3862945, which is equivalent to 2 to the 1 times 0.693. So then let's see what happens if you take the slope of 2 to the x at x equals 2. Well, then you get 2.773. This is 2 to the 1 times 0.693. This is 2 to the 2 times 0.693. Well, finally, let's see what the slope at 3 is. Well, what do you know? It's going to be 2 to the 3 times 0.693, which means that there is a magic number. But how do we find that magic number? How do we find what K is? Kelly's going to teach you whenever you're ready.
Okay. So first, let's try using the limit definition to find the magic number. So in this case, you would write f of x equals, well, the original formula is the limit as h approaches 0 of f of x plus h minus f of x over h to review. So we'd plug in here our 2 to the x. So we have the limit as h approaches 0 of 2 to the x plus h minus 2 to the x all over h. So the first thing we would do is we would split this up into two different exponents. So we do, write this again. We have 2 to the x times 2 to the h minus 2 to the x all over h. And since both of these have the 2 to the x, we can factor that out. And once we factor that out, we'd have 2 to the x, and then we'd have 2 to the h minus 1 all over h. And the next thing we do, we can multiply this over here on this side. So we have f prime of x equals 2 to the x times the limit as h approaches 0 of 2 to the h minus 1 all over h. But again, here we couldn't go any further because it's the magic number. So we'd want to move to a different method. So to start, we'll start with our equation y equals b to the x. And for this, we want to make sure that x is down in order to be able to solve it later when we do derivative. So the first thing we do is do ln to both sides. And then that will get us natural log of y is equal to the natural log of b to the x. And then from there, that base, we are allowed to move this down here because of different properties of natural log. And we get natural log of y is equal to x times the natural log of b. So now once we have that, we can take the derivative. And to do that, we'll do dy over dx to both sides. So on the left side, we know that the derivative of natural log is 1 over the variable here. So we'll have 1 over y. And on the other side, we'll be doing the multiplication rule. And remember, this is, because the multiplication rule, we'll be doing addition. So on the left side, we'll have x times, in this case, 0, because it is a constant, and derivative of any constant is 0. and we'll add that to their side. And we'll have 1 times in LMB because it's a constant. So when you simplify that, you get dy over dx. Yeah, dy over dx equals, or 1 over y. You simplify that and you get, let's cancel out, LMB. So once we have that, we can just multiply both sides by y to isolate dy over dx. And we'll get dy over dx equals y times LMB. So in the beginning, we stated that y was equal to b to the x. So we can plug in b to the x. Here we have the y. So once we do that, we'll get the derivative is equal to b to the x times LMB. And LMB is the magic number that we had earlier.
So let's prove that Kelly is completely correct in her use of the magic number. The ln of 2 actually does equal exactly 0.693147, which you can see is the same number we got up here.